Good evening and welcome to Herding Cats 106. Tonight, once again, we have Rodney Black, the author of the Cats software package, with us. And he is going to take what we discussed over the last two classes, how to wire your layout and understanding signals. And we're going to tie that all together and show what Cats can do for you. So with that, Rodney, you can take over, and at some point there will be an intermission, impromptu, to give Rodney a break, and then we'll continue. Thank you, Rodney.
Okay, let me share my screen. There we go. Okay, good evening, and it looks like we got somebody from Australia, so good afternoon. Yeah, this is episode 106. I put this cartoon up because this is one of the I guess you'd say that the plus side of the COVID for this year for Thanksgiving. It'll be just my wife and myself for dinner, and what that means is that I don't have to get this pop-up fullness indicator installed. So, there we go. So tonight we're going to talk about cats, and this is going to be the culmination of the last 3-4 sessions that we've done. And like Jerry was saying, this presentation, I haven't been able to get it under an hour. It'll probably be close to an hour, 15, hour and a half. And what we can do is at about the 45 minute mark, I think there's a fairly natural break. What we will do then is we can decide if we want to just break for intermission for a while, or just keep plodding along, or to, just shut it off for the night and pick up again in a week or so. So what you can do is in your chat, if you've got preferences, just say something. Now, I won't be looking at the chat simply because it takes up too much screen space and I can't see the stuff on the right side of my screen. So do something like that. Like I say, this is the culmination, and I'm going to be pulling a lot of stuff into this talk from things I've mentioned over the last 3 sessions. So you'll see some slides that look a little bit familiar, and I'm not going to go over them in detail, but they're more of a reference. It's to go back, and where you find that slide in a previous talk, it'll have more information on it. And as I go through this stuff, I'm sure there'll be some thoughts triggered in the sense that there may be some more areas that you want some detail. Again, put those into the chat. I don't know if the chat shows up on the recordings or not. And if they don't, Jerry, could you take notes about what people are interested in hearing about in the future?
Will do.
That'd be appreciated.
Yep.
Okay, so outline, quick introduction to cats. Saw a lot of this stuff in, I think it was Herding Cats 102. We'll look at some prototype examples of dispatcher panels. We'll look at a few panels that some of my cats users have developed. And most of the talk will be in setting up cats as a better magnet board, just to show you what can be done without any layout connections. And then it's a fairly simple step then to go from there to hooking cats up to your layout and using it. Again, this is off of, I think it was Herding Cats 102. CATS is a computer program for controlling the signals on model railroad. It supports ABS, APB, CTC. Last week we talked about various disciplines. It's a dispatcher's panel for a model railroad. It's also a model of a dispatcher's panel. I tried this once because in a local model railroad group that I belong to, we had every meeting they have a modeling contest. And one night the contest was open, bring anything. So I brought my laptop with my CATS panel on it, and I put it on the contest table, and a lot of people weren't happy. But it's also a suite of programs to assist in operating a model railroad in a prototypical manner. We'll hit all 3 of the programs that are in the CATS suite. Like we said in Herding Cats 102, it's computer system independent, works with Linux, Windows, Macintosh. It's not tied to a particular control system, used with NCE, Digitrax, Lens, pick your poison. It's not a it's a JMRI application, so it's not part of JMRI. It's not Panel Pro. It's freeware and open source, and bringing along with it everything that entails. And it's inspired by Digicon. Okay, the premise of CATS, as I'm developing it, is that, and the reason I turned it over into the public domain like this, is my theory, my premise is that if an owner can describe the layout graphically, the computer should be able to determine the connectivity and generate the proper signal indications and logic. What was interesting, I was at, I think it was the Cleveland National Convention. I was in the LD, the SIG room, and I think the LCC guys had something set up, and I was walking over and looking at them, and there was one of the attendees was talking to one of the LCC guys and said, well, I said, that can't be done. There's no way you can do a computer program that can understand all this stuff. You have to hand build and tailor all the control points and signals. So, I just kind of smiled and walked away. So the primary CATS user, who's my audience? My customer. And that's the model railroader who wants a kit. And I put kit in quotes for signaling. I can't give you a ready to run out of the box type of thing because everybody's railroad is different. Therefore, I want to try and make it simple to set up. I want to make it simple to use. I want to make it realistic. By simple to set up, I mean in my circle of model railroaders, I have only one person who's a signal engineer. You shouldn't need a signal engineer to get a signaling system that does something reasonable. It looks good. If you're fortunate to have one, then you can get the stuff right. But the downside of having one is if you don't have it right, you're embarrassed because he can tell you what's wrong with it. Also, I try to set CATS up such that if you do have a signal engineer, that he should be able to help you get it exactly right. Simple to use. We talked last week about the realities of dispatching a model railroad. We don't do dispatching day in and day out like the pros do. Interestingly enough, I had also a couple of dispatchers who were in our model railroading group circle once upon a time, and they refused to dispatch. They wanted to run trains. But anyway, these guys do it all the time. In model world, if you're lucky, if you get dispatch once a week, maybe once a month, and now it's maybe once a year with the COVID restrictions and everything. But the idea again is that if you got a rookie coming in, sit him down in the chair, he's got maybe 10 minutes to learn the layout. He's got 10 minutes to learn the dispatching system. So it's got to be simple to use. And at the same time, I'd like to make it realistic. My secondary CATS user is the purist. Believe it or not, we have the equivalent of rivet counters in the signaling world. They want it to be exactly right. I'm welcome to suggestions, and I'll admit that's my temptation to the dark side. It is like any model. You try and make it just as good and accurate and realistic as you can. But my theory, my philosophy is that if making it realistic makes it harder to set up or harder to use, then I will opt on keeping it simple and over realistic. I know you guys can read, but I'm going to read this because I just love this quote, and it kind of touches on some of the things we were talking about a little while ago. Wayside rail signaling practice in the U.S. is a nightmarish web of operating rules, signal types, aspect names, and indications, differing between the different roads and even their individual divisions and locations. Much of the protocol involved is extremely curious and often counterintuitive, result of the long historical evolution of this field and of the industry. Now, what I look at, this is the challenge I'm going to try to overcome here. So let's look at some examples of dispatcher panels. This I got from a Digicon brochure, and I can't find it on the internet anymore, so I'm glad I grabbed it when I did. And this is what a typical panel looks like. I'm going to bring up my laser pointer here. And it's basically split into two pieces. The top half is where you do the actual dispatching. The bottom and the dispatching has codes in it. Like I think that if I blow up, it says something like C4. The bottom half then is the legends. It's the keys to understanding what's up here, and it gives the dispatcher a little bit of information. CATS will focus on the top part. And when I did it, computer screens weren't big enough to do the bottom as well. So we'll just do the top. Here's another example I pulled off the internet. This is a Digicon screen. And let's take it apart and see what we can get out of it. Well, first of all, notice there are no scroll bars. And I think on the prototype, that's very reasonable because you don't want something happening on a piece of the screen that's not in the view window. And I use that as a rationale, saying I don't have scroll bars in CATS. And the real reason behind it is I couldn't figure out how to get scroll bars to not conflict with some of the other things I do in CATS in terms of resizing the window. At the time I developed CATS, you got to remember that CRTs were the computer monitor of choice. And there weren't any flat panels. CRTs were, you know, if you were rich, you had one that was 19-inch, and if you were really lucky, you had a 21-inch. They were SGA, 640, I'm sorry, 680 by 460, whatever they were, 480. So you couldn't get very much screen on them. And the emphasis then was how much track plan can I get on a screen? Now with 32-inch monitors and, you know, high res and all that kind of stuff, what we're finding is that people want, how can I blow up my layout such that it fills my screen? So we got just the reverse thing, unless you're doing something like on a tablet or a laptop or something. Anyway, let's see what we got here. First thing you see, there are lines. Of course, the lines are tracks. The tracks are color coded. White says that it's idle. There's nothing going on. We've got some green lines down here with arrows. These are the routes that a dispatcher has set. And in fact, in this case, it's probably the computer did it, because the A up here says that this control point is in automatic mode. We've got some red lines down here with arrows. These are where the trains are. We have the train labels. The identifier for the train is on top of the label. We've got a crossover here, which the switches are aligned for reverse for the crossover. We've got another crossover in which the switches are set for the through routes. We've got these things that look like aerial bombs. These are the signals on the control points. The little triangle at the base shows you the direction of travel for the train that the signal is for. For example, this signal is for trains going from left to right. This signal is for trains going from right to left. We've got control points labeled, some color in terms of where stations are, things like that. But if we back up and we look at this, a couple of things should really stand out. First of all, this track connects to this track down here. This track on this end connects to this track down here. Notice this is not to scale. For example, this siding is 4,600 feet long. This siding is 8,400 feet long. And on the drawing, they look like roughly the same length. And in fact, if you look at the control point, which is probably a few hundred feet long, it's as wide roughly as the siding is. Notice also that the track is straight as an arrow. I really doubt that the prototype, it goes this straight. You don't see industry sidings. You don't see bridges. I'm not really sure what this is. But the point is that the dispatcher panel has only the information on it that the dispatcher needs, nothing more and nothing less. You don't put more on it because it's distracting. You don't put less on it because then the dispatcher can't move trains properly. So don't try to make a panel like you would do a drawing for an article in Model Railroader magazine or something like that that describes your layout. What makes this panel interesting, and the reason I was able to get it off the internet, was because of the activity that's going on down here. If you notice, the date is September 12th of 2008 at 4:22 p.m. We're on the Chatsworth sub down in Southern California. The dispatcher has train M111, which is a commuter train headed westbound and approaching a stop signal because he's got a freight train coming into the siding. And what's happening is the engineer is texting, so he misses the signal. And this is at second 00. 16 seconds later, you can see that the occupancy disappeared. 5 seconds after that, you can see that the color of the label changed, indicating the computer is seeing something's terribly gone wrong here. And about another 6 seconds after that, you can see that the occupancy has disappeared, and indeed something very bad has gone wrong because M111 has plowed into this freight train. So, and if you're interested in that, I think you can still find it by looking for this information on the internet, and you can get the whole report and the sequence of the screens. What this is, this came from Digicon. They record what's going on, and this is just a playback. So let's look at another panel. This is the CAD panel from the Union Pacific, and a lot of the stuff should look fairly much the same. We got white lines for idle track, turnouts. In this case, the signal icons are just dots. Red indicates that the signal is red. Green up here really means that it's not red. So there's probably some type of route going on. Same type of color, green for routes. We've got red and arrows for occupied track. We've got some other interesting colors, like right here, we've got some purple for out of service. And specifically, this is the Moffett line from west out of the Moffett Tunnel on the old UP. And the reason it's out of service is because the curtain is down. So they're venting the tunnel. We've got some light blue lines down here with some numbers on them. So this is probably some work going on. And these are the work warrants. And the way this one works now is this track is connected to this one. And this one is connected to this one down here. You can kind of see that because of the way the warrant numbers line up. So they did it completely backwards from the way Digicon did it. What makes it interesting is the activity that's going on right in here in Winter Park. If you look at it, you say, well, what's happening here? Because we've got two westbound trains on the siding and the main. We've got eastbound trains, so clearly there's no place to put it. Oh, and these blue boxes indicate the signals are either under local control or they're in motion or something like that. So what's happening? Well, what happened is that this freight coming in, trying to get into Winter Park, there's a little bit of a grade here. He pulled a coupler right about there. And I'm sure what the dispatcher really intended was to put him into one of these tracks and route everything around him. But since he pulled a coupler, then he's kind of stuck there. I don't know if the dispatcher lined these up so he could back up, or this is residue from trying to get these trains through. That's bad enough. But it gets worse, because see this green arrow over here? This green arrow is the ski train. It's brings a bunch of skiers up from Denver. What they want to do is they'll go into Winter Park, they'll unload the skiers. The train wants to go down to Tabernash where there's a Y. We turn on the Y, and I think he lays over in Tabernash till late in the day. Then he comes back, picks up the skiers, and heads back to Denver. And it gets even worse after that, because what you don't see is that several miles behind the ski train is Amtrak number 5. And Amtrak number 5 wants to go through here. He wants to go into Fraser, do his passenger stop, and continue on. Needless to say, the dispatcher is looking at 4 trains wanting to go westbound, 1 that wants to go eastbound who's got a broken coupler, and everything is a real mess. So let's look at another example. Sorry for the blur, but this is the BNSF TMDS system. And again, it's good enough that you can kind of see similar type stuff. White track for idle, red track for where trains are, green track for where the routes are. The signals here again are a circle with a little triangle in the base of them. Very common type, similar type things. And even more blurred. This is a TMDS on the Montana Rail Link. This panel is I think of their whole system, so it's kind of like the 50,000 foot view. So let's look at some examples of CATS panels. This is the original CATS. This is for Pat Lana's in-scale Kranich layout. Similar type stuff you see. I don't have any trains going here, but you see white lines. Some of them are gray. This is track that's not detected, called dark territory. We also have some signals like right down in here that don't exist. So they're here primarily for just the purposes of the dispatcher. They're gray, telling the dispatcher that he has to tell the crew what color those signals are. Pat uses some semaphores. So I added some semaphore icons to indicate where his semaphores are at. We added a picture up here. He likes the compass, so we can show the dispatchers which way is north, which way is south. We've got one set of track over here. That's ABS. This is the switching lead into his yard. And so the signal is always red to indicate that it's an automatic signal. The tracks over here down the left side connect up to the tracks on the right side. And I saw John online. I've got an old picture from his layout. So this is John Parker's BNSF Fall River Division. Notice that John used a different color for the background. It's a lot larger layout. And he's got different colors and fonts on his labels and stuff. Another example. This is Don Meeker's Rocky Mountain line. And he customized it by, again, with the use of color and fonts. This layout has been torn down, and Don is now working on the second generation of it, which will be smaller. I like this panel. This was Chuck Shell's PRNC, Powder River and Chugwater. Again, use of color and fonts. Unfortunately, Chuck passed away a few years ago, so this layout is also gone. But the thing that they have a lot of similarity, but at the same time, you can see how they've customized them for their own tastes. So let's get into setting up CATS as a better magnet board. Here's the plan. I'm going to take just a track plan. I'm going to convert it to a CTC panel diagram. We'll draw the main line, add some blocks, some turnouts, some signals, and then we'll show you how to run it as a magnet board. And this is probably about the point at which we will stop for a break and take a poll and see what people want to do. Here's the track plan that I picked out. This comes from Track Planning for Realistic Operation by John Armstrong. If you look at this, this is kind of like the poster child for spaghetti bowl layout. It winds all over the place. The reason I picked it, though, is one of the things that John did was he gave us a linear diagram. This is basically the track plan for his dispatcher panel. Notice how it's nice and straight and everything. Question is, did he do a good job of making it linear? Well, let's pick out a few items to see. This is obvious. The turntable, we got a turntable. It's got one ray coming out here. It has a lead coming off with a couple of tracks going the other direction. That looks like this. If we look at this other side of it, we got a kind of a crossover type of connection, which goes into hidden track that comes around in a big loop. Yeah, that's this. Another obvious feature is the Y with another hidden track that comes around like this. Yeah, that looks like it. I think he did a good job. So let's demonstrate how you build a magnet board. This is a game plan that I'm going to use, and this is kind of a cheat sheet for me. So what I want to do is I'm going to minimize this so we can go to the lab, so to speak, and look at what's going on. Okay, let's let me bring that back up. There we go. Okay, first of all, let's look at the installation. This we talked about in, again, Herding Cats 102. Let's start with, here's my shortcut icon on the desktop, and I'll look at the properties. I'm running, as you can tell, I'm running Windows 10. Okay, so my files are in users, Rodney Cats dash users, and it's designer.txt. So this is a shortcut to that. If I bring up is. This is users Rodney, CATS users. And let me go back to here a minute. I should have done this earlier. Okay. So I said designer needs to be, can be anywhere. You can needs designer.jar, designer.that, and the lib. So I go into here, you'll see there's more stuff in there than that. But there's designer.that, there's designer.jar. I've got these icons, which are in the distribution that you can use, and that's what put the icons on the shortcuts over here. If I look at lib, you'll see I've got jdom2.jar and a log4j.jar. And this one is because I've also got TrainStat in the same folder. That's why I put this library in there. So that's basically how I installed it. Cancel that. I'm going to minimize this. There we go. Okay. So let's more or less do this in this order. I'll launch Designer. There we go. And I'm going to minimize that. So to design a layout, you use the Designer program. And it works on kind of like a spreadsheet kind of analogy. In other words, you've got columns and rows and squares, and we'll just put tracks in the squares. Like all good programs that use the file system, you have to have a file drop down. I look at it, new, creates a brand new dispatcher panel from scratch. Open lets you reload one that you've been working on. Again, very standard type stuff. Save to save your work. And what I want to note here is that when you do save, if you've opened a panel, well, you got to give it a name. And if you try to save the panel under a name that already exists, what happens is CAT will put a .back on the end of the name, and it'll give you one level of backup. For example, if we go back to here, you'll notice I've got a Armstrong full.back and an Armstrong magnet.back. So these are my backups. And the reason, the thing to note about that is if Designer should crash on you, particularly if it crashes while you're saving your layout, the thing to do is stop, take a deep breath, and if you've got a backup file, copy it somewhere else, make a copy so you don't lose any changes. It's like a one level safety net, because if it crashes again, well, you're trying to save your backup and you could lose all your work. Save as does not change the current file name. So if I open this as, panel.xml, and I save it as panel1.xml, then I do another save, then it'll save in panel.xml. So it sticks with the file name you opened it. First of all, the next thing is for some quirk in Java that I haven't figured out, you can't do save as with using the same name twice in the same session. So I think Java is keeping some file handle open or something. You also notice there's an import. What you can do, and this is primarily for module users, what you can do is save, create a panel for each of the modules, save them. When you go to a show or put the modules together, you open a brand new Designer session, import the modules in the order in which they're hooked together, and save it. Now you've got a dispatcher panel for the module set up as it currently exists, as you have it set up when you do it. Again, you got to have an edit. Undo, redo, and paste are, work with a clipboard that's built into CATS. You can't share it outside of CATS, but they do this standard type stuff. Undo the last operation, redo it if you forgot it. My only caveat here is if you're undo, redo, pasting something that's large, you probably want to save first, because I've seen occasional failures. And how you use these is you highlight a region and select a bunch of cells and just do the operation. Clear will clear out a region, and what it does is it takes all the track plan that's in that region and puts it on the clipboard exactly like it is. Copy will doesn't clear it out, but it'll put some on the clipboard, but it puts just the structure. It doesn't put on the clipboard the names and decoder addresses and things like that. The thought is that if you're going to copy something, you probably want to paste it somewhere else. And you don't want, for example, 2 blocks with the same name, and you don't want decoders tracked in 2 different places that have the same decoder addresses. The clipboard will carry over between files. So you could, for example, you could load a program or load a layout and copy it or clear a big chunk of it to get all the data. Then go up here, do a new, and then do a paste. So that's how you can move part of your layout from one file to another. Things to notice is that insert, down here you can delete rows, delete columns, insert columns. Again, you're adjusting the geometry of the track plan. And if you do an insert, you can split rows or basically split up blocks, in which case you'll have 2 chunks with the same name. You can delete columns in which you merge things together, and you better check and see, if you merge things together, which block name superseded the other, what your merged block is called. Okay, probably the first thing you want to do before moving on and actually laying track is go to devices, go down to JMR devices, and you'll get this table. This is a list of the system prefixes that you'll be using. I'm going to go over here a minute. And again, from CATS 102, in your JMI profile, you got the connection prefix, and that's a letter. That's the far left column here that talks about the layout connection. And then the next letter is the connection type, and this stuff you don't worry about, except it's a nice little indicator of what your connection is. And what I'm going to do tonight is I'm going to use internal sensors. So I'll just check that. I'm going to use internal turnouts. So I'll check that. And I'm going to do a local net simulation as my layout connection. So I will check local net simulator or local net sensor and local net turnout. Accept that. Okay, let's see what my next cheat is. Okay, so let's lay some track. Let's go back to edit, and I'm going to insert, let's just do an insert row below, and you'll see I've inserted a row. I'm going to move it over here, and I'm going to insert a column. There we go, insert column after that. Okay, and this gets a little tedious using the cursor. If you notice, we've got shortcuts over here. So I'm going to make it a lot wider by just going here and doing some Control Y's. And you see I've basically expanded the canvas that I'm working on. And I could do Control R's and also then expand it in the vertical direction. So let's lay some track. We'll go here, position. This is your cursor on the panel. We'll go there, and we will select Details, Tracks. The idea is a track connects two sides of the square, and there are only 6 possible combinations. Trust me, you can't get any more. Some people say, well, how can you get all these elaborate track plans with only 6 combinations of lines? And my flippant response is to say, well, physicists tell us that all matter in the universe is composed of 6 quarks. So I figure if you can do the whole universe with 6 quarks, we should be able to do all track plans with 6 lines. And what I'm going to do is I'm going to put some horizontal tracking here. So I click that. I could also click here. Notice that highlighted this. And here I could set the speed on the track segment. For most of the things you do, default's going to be good enough.
Rodney?
Yeah.
We have a request if you could zoom in at all to make that larger.
I don't think I can. Is there a Windows operation that lets you zoom in?
Probably not without changing the resolution of your monitor.
You can go into magnifier and try it that way.
Okay, how do you get the magnifier?
Go down to search, down at
okay.
the bottom. Just type in magnifier. There it is.
Okay, let's give it a try. Did that do anything? Oh, there we go. Okay.
Thanks for the help.
Okay.
Yep.
And I'll move up here and see if I can. Oops. Okay, let me try it again.
It can be a little fussy.
Okay, let's see if we can. There we go. Okay, so you can see that we've got, you can set your speeds here on the track, and usually default's going to be good enough. So let's just accept it, and that puts some track down. I'm going to move my mouse cursor over, and I'll select the next grid, and let's do the same thing. We'll do details, and we'll do tracks, and we will do another horizontal, and we'll do accept. And you can see that things get a little bit tedious. So what I'm going to do is I'm going to move my mouse cursor over here. I'm going to hold the shift key down and click it. So now I've highlighted region. I'm picking up 2 chunks of track. I'll go up to edit. I'll go up to copy. I'll move my mouse down here. I'll go up to edit. I'll go to paste. And okay, let me try again. Yeah. Okay. Let's do it this way. Edit. Copy. Move it over here. Edit. Paste. And you see I've doubled it. Now, since I've got it on the board, I'm just going to use my arrow keys. And Control V, Control V, Control V. Okay. So by using the arrow keys now, I've made it go. I've laid track a lot faster. Now, the track is red. If you see red track, that says CATS is going to get very upset if you try to run this panel. And the problem is that this track is not in any block. So we have to give it a block name. Go to details, track ends, and okay, go up here. And notice that the excuse me a minute, I don't want this one. Let's see if I can. Come on. How can I move this?
Rodney, you have to drag the magnifier out the way, not close it.
Yeah. So I can drag it up high or something. There we go. Okay, so I'm going to cancel that. What I want to do is I want to put a block boundary here. There we go. Okay, now let's do details. And we'll look at track ends. And we've got this. Notice that when I come down here, the track touches 2 edges of the square. It touches the left edge, it touches the right edge. If I look at the edges, here is how is the left edge, here's the right edge. I want to put a block boundary on the left edge, so I click this. That enables these boxes. I'm going to define the block, and I'm going to give it a name. I don't feel very creative tonight, so I'm going to call it left. And I'm going to make it CTC. If I wanted to put a station on here for operations, I'd put the station name in here, and I'll accept this. So part of the procedure here is whenever you do something, you have to accept it. And I did that because so people, they make mistakes, they can always cancel out. Now notice that the track is turned from red to a dark gray. It's dark gray rather than white simply because I didn't put any detectors on it. So now CATS will take that. Let's go over here, one more block, and let's do details, and we'll put a block boundary on the right-hand side of the second one. I click the block, and if you want to see, if I define it, it has the same data from the other end of the block. So I can cancel that, and I'll accept this. Turn red again. Why did it turn red? Well, because the track is now into a unknown block. And what I'm going to do is make this one ABS. And so here, this is where you would select your your discipline. I'll give it a name. We'll just call it middle. Something like that. And we'll accept that. Okay, now where's my, I want to get out of the, this for a minute. Magnifier. Okay. So let's accept that. It's happy. The reason I got out of here is because something that we talked about last week, and it goes like this. The control points are the triad, the sections, the signals that the dispatcher can control directly. And typically CTC is control points tied together with absolute automatic signals. And I don't know exactly what that means, but there tends to be two ways that these signals should operate on the intermediates. One is that they show, if they're true automatics, they would show like green and yellow whenever it's idle. And what I've seen in the model railroading world is often they will make the intermediates red even when it's idle, so that when you create a route, you remove the hold on the signals to make them look like this. And I imagine the prototype does, you can find some prototype that'll do one, some prototypes will do the other. So the point being here is that if you're doing intermediates and trying to decide what to do for your blocks, if you want them to look this way, then you make your discipline ABS or APB. If you want them to look this way, then make it CTC and CATS. One other thing I should mention here then is, let's go back and look at the, again, back to the block definition, and is that there's APB2 and APB3. In CATS, I had some ideas for what I thought they would do, but they would be different, but they're exactly the same, so you can select either one. It doesn't matter. Okay, let's now put in some turnouts. And we will go back to detail. Let me do magnifier again. And okay, let's go back to here, details. Let's put some more tracks in. And I'll go up to here. What I want to do is put in a turnout. Let's see if I can do that. Goes from the left-hand side to the lower, to the bottom side. And all I got to do is look and see, okay, this is left-hand side to lower bottom side using my picture here. And I'll select that when I can click on it. And again, I've got my default speeds. I'll leave it as default. But what CATS does is, and this is the whole reason for the default, rather than specifying it's normal. CATS will see that diverging route is the diverging route. And so is somebody? Okay. And so what'll happen is it's the diverging route. And so what CATS will do then is it will internally change it into medium. The reason, so that what I'm trying to say here is that gives you, by default, you say, I want it to be medium as opposed to specifically a slow or limited or slow or limited. And this is just a convenience for when you're designing your panel. So let's leave it at the default. We'll do an accept. And notice that again, we've got red track in here, which says CATS isn't going to like it. So we go back to details, go back to track ends, and notice that we've got the tracks touch the box on three sides now. It touches it on the right, the bottom, and the left. In fact, there are two tracks that merge on the left side. So I go back to the track ends. There's the bottom definition. There's the definition for the right. And designers recognize that I've got points on the left side. So we'll define the switch points. We'll go over this screen a little bit more. But the reason that track is red is because one of your routes has to be a normal route. See, if I select bottom and right, neither one's a normal. So let's make the right side the normal route. Now you can see that they're different. We'll accept that. And we'll accept that. And now it's happy. let's go back and let's put a, so that's how you put turnouts in. You can actually do three-way turnouts if you want. We can go back here, let's go back, and sometimes you'll get multiple squares selected. I think that's because of how Java does the mouse cursor stuff. Let's put a signal in. So we'll go to details, go to track ends once more, and I'll define a signal. Notice, okay, the way this box comes up is that the top half is it tells you where is how you place the icon. The bottom half talks about how the signal is connected to the track. I don't have any signal types defined, so we're gonna have to do that. So I'm gonna cancel out of there. I'm gonna go back to devices. We're gonna do a signal template, and I'm gonna do some speed signals. I'm going to call it speed 2. And what it's going to be is going to be speed signaling 2 heads. And you can call it anything you want. So I'll make it 2. I'll do a lap. Anytime you define the signal template, always do create aspects and hit accept. And the reason is otherwise this chart doesn't get created. Now, the reason I did the tracks, I put some track down before I did this, is because, and I'm going to get out of here once more. Let me go back to here. Okay, the reason I did this, I did track first, is because I have now some speeds established. In other words, designer looks at the speeds of all the track segments I put down. I've used only a normal speed and a medium speed because that's the straight track by default is a normal speed, and the normal route through the turnout is normal, whereas the diverging route tends to be medium unless I change it to something else. Since I haven't used limited and I haven't used slow, then the limited column and the limited row has been grayed out. They're not being used. The slow column and the slow row has been grayed out. It's not being used. Now, if you compare this to here from last week, and again, I apologize that this may be kind of small on some of your screens. The fundamental principle that CATS is working on here is that the indications for most railroads are the same. It's just the indication names and the aspects that change a lot. So if I look at normal, and speed routing, I go over here and I should say green over red. Yeah, there's green over red. If I look at normal, medium, and speed routing, I got normal, I have medium, it's yellow over green. Okay, let's make it yellow over green. And I could do that for all the rest of the cells. And I'll accept that. Now I have a template for a 2-headed speed route. Let's do, and I can also do one for route signaling. I'll call it route 2. And it's 2 heads. Get it? It's a lamp. I'll create it. And in this case, I would do, if I wanted to do normal medium, it would be yellow flashing over red. So I go over medium, yellow flashing over red. That's yellow over red. And save that. And save that. You can have as many templates as you want. In fact, you'll want some for single heads. You may want some for dwarfs. Any place that your signals are different. So, okay. And with that, I am going to do the, since we're close to Thanksgiving, I'm going to do the Martha Stewart trick. You know how she goes on her show and she stuffs the turkey, spends 20 minutes and slaps it in the oven. And, you know, rather than twiddle your thumbs for 8 hours while the thing bakes, she pulls one out that she's been baking for 8 hours. So I'm going to do the same thing here. What I'm going to do is I'm going to open a pre-existing layout, and these are in the distribution. Come on. There it is. Armstrong magnet like that. And now the question is, does this match? Let me show you this. Here is that linear diagram that Armstrong showed us earlier. And the question is, does this match? And I'll stretch this out. And drag it down a little bit. Now, if you drag too far, stretch this out too much, you get those lines. Don't worry about it. That's all due to the way that CATS draws each of these individual squares. Is its own little canvas in Java. Now, does this match that? Well, it looks pretty close, except notice here we've got some hidden track, and those don't connect up like they do down here on this loop. Well, actually they do. If I go on that and I look at details, track ends, notice that checkboxes, this box is not checked. On the right side says it's joins to adjacent track. In other words, this end lines up with, connects to that end. Since this is not checked, the left side lines up with column 1, row 4, left side, column 1, row 4, left side. So these tracks actually are connected. And this is useful for something like if you're doing a flyover where you have tracks crossing each other, but you don't have a diamond. They don't cross at grade. Instead, one crosses like on a bridge across another one. So that explains that. But then if you look over here on that other hidden track, say, well, it's hidden over here, but it's not over here. Actually, it is. If we click on here, and let's go back to details again, go to track ends, we'll look at the block. Notice that show block is not checked, and which means that when CATS tries, it won't put it up on the panel. The space will be there, but there won't be any track. So that's why I made that hidden track. The thing to note, if you do this, put in hidden track, the signals are also hidden. So if you've got a control point that has CTC, it'll always be red because the dispatcher will never be able to click on it to set the signal. And with that, it's actually about 55 minutes. Why don't I take an intermission and we can decide what we want to do. We can just plow on, we can take a short intermission, or we can break here since some of you guys probably have to get up for work tomorrow morning and stuff. And I'm turned back over to you, Jerry. Okay, I'm going to go back to this screen and let me go back from current slide. Okay, so that's basically the how you build a panel, and I'll add a couple other things to it here as we go along. So let's talk about what does a model railroader do, and what are your dispatching tasks as a dispatcher? Well, the obvious one, the most important one, of course, is you direct the trains. You throw turnouts and you set signals. That's your primary job. You may also unlock turnouts for local use, and you do that by granting track authority through CATS. But in order to know which turnouts to throw and which signals to set, you need to know where trains are. So you have to follow a train's progress. On some railroads, you fill in a train sheet. You log the times that the trains go through a station or something like that. You need to know where the trains are so you know which routes. Personally, I hate train sheets because when I'm dispatching, I always forget to fill in the train sheet. So CATS lets you put labels on the panel, and you can move the labels around kind of like a magnet. So then part of the dispatcher's job is to add the train labels to the board and move the labels. Often I find that on model railroads, the dispatcher also is the crew caller. So to do that, you must know who is on each train and who is free. Okay, now I'm going to go back to, this is This is basically the user manual for 90% of CATS. CATS uses a Microsoft paradigm. In other words, the left mouse button has immediate action and the right mouse button brings up an object-specific menu. And we'll look at these in a minute. So let me go back, minimize that. I'm going to go back to bringing up CATS and show you installation again, properties, and I don't want to bring the magnifier because I'm not going to be here that long. So basically, the CATS stuff is stored, the JAMRI or the jar file and the batch file are in C programs x86 JAMRI, which means that I'm currently running a 32-bit version of Java and a 32-bit version of JAMI for CATS here. So let me fire up CATS. Yeah, click on it. Here comes my profile selector. I've set one up specifically for us for tonight. I call it CATS users. Go do OK. And first thing you're going to see is this window is from operations. This is the train window from operations because I'm going to do a few things with trains. It takes a little while to come up. So I'm just going to kind of spin my wheels here and as I wait for this to happen, and I'll show you why in a minute, why it takes so long to come up. And it's blinking. There we go. So here's blank CATS window. Go File. I'm going to go Open, and I'm going to bring up our magnet board right there. And there it is. Well, gee, it doesn't quite look like this, does it? And the reason it doesn't is because this end is down here. What happens is the window width is smaller than the track. So what CATS did is it started at this end and it worked back until it found the minimum number of tracks to break it on, and it then moved that down here. So it's kind of like a word processor where it figures out what words to move to the next line. There's an easy way to make it all line up, and that is to go do that. Okay, so now it's all, you can see how CATS does this. If you don't like that kind of behavior, then go down to, here's Designer, and go down to Appearance, and you will see there's something called automatic wrapping. Turn off automatic wrapping, and then CATS will run the tracks out to the end. This is also very useful if you want the diagram, you don't want CATS to do any reformatting of the screen, any screen adjustments. So in other words, you could put one track line up here and another track line down there. There's also something called compress screen. And what that does is it tries to take chunks of horizontal track, and if there's nothing above and below them, it cuts them in half. This again was back in the days when we had very small monitors. How much can you get as much track on the screen as possible? Something else you can do, and I'll show you. I'm going to compress this down a little bit. Let's go over to the JAMRI splash screen help. Bring up the system console. And I have to do this because I see you guys and I don't see the scroll bar. If you scroll down, you'll see that there's this bunch of stuff that talks about rectangle, XY, width, height, and all that kind of stuff. For some reason, Java doesn't tell me when I move the panel, but if I adjust it, notice I'm getting new reports on the size of the panel. So go back to your Designer and go to Appearance, go to Screen Size, and you can put in these numbers. And if you do that, then CATS will, when you launch CATS and you load this panel, it'll place the panel exactly where you specified here, and using this is the XY of the left-hand corner, and then also the length and the width. So, little trick. Okay, so let's go back to get rid of some of this stuff. And mouse buttons. If I put the mouse, maybe I can use the magnifier here. Okay, let's do that. There we go. Okay, if I put the mouse over a signal and I click on it, and you probably want to go close to the block boundary. That's how I set a route. Set a route, click it again, clear a route. If I do a right button click, it'll bring up a menu, and allow traffic doesn't do anything. I don't even remember why I have it in there anymore. But I can turn on fleeting and turn off fleeting just by clicking that option. Okay, if I am over a train label, so how do I get a train label? I'll do edit lineup, and we don't have any trains defined, so I'm going to do that in a few minutes. I'm going to cancel that. If I'm over just any other place, for example, let's say right here, and I just do a left mouse click, I throw the turnout. If I do a right mouse click, I can force occupancy or unforce occupancy. What's interesting is some people say, well, why would I turn off occupancy if the layout has told me that this block is occupied? And sometimes you just need to do that, for example, to clear a signal. What's really interesting is I happen to have a user manual for a prototypical CTC system, and they also have an unoccupy option. I can grant track authority. So this is how I unlock turnouts. And I mark the track as being, that it's being worked. I can take it out of service, and I can position a train. So let's, that begs the question, we need some trains. Okay, so what I'm going to do is I'm going to go back to the trains menu, click on it. I'm going to load a lineup. What I have done is I've pre-configured. I'm going to do some trains for this. And I'll open it. And for some reason, CATS does this. It's so seldom that I don't have the crew. So seldom. Usually, what I do is I have the screen sized, and for the panel for this, I don't know. This is going back to the initial positioning, but anyway. So let me pull this down. This is a bug I didn't even know I had. It's probably been there for years. Whoops. Let's go this way. There we go. Okay, I'm going to get out of here again. There it is. And the thing I want to do is pull this down. This. And let's edit the trains. Let's look at the lineup. Okay, there's my lineup. Notice that the lineup looks a little bit like what I have in operations. Specifically, the train symbols here are identical to the train names there. That's the linkage between operations and CATS in terms of the trains. And then the station names are the other linkage for locations. Anyway, okay, so I've got my lineup. I'm going to assign a crew, and I don't have a crew either. So let's load a crew. Go to crew, load crew, and I'm going to load this crew today. And again, it went back on me. So let's go back to crew. I'm going to edit the crew, and we're going to have the Beatles running the layout tonight. What we're going to do is we're going to assign John to train number 1. And I'm going to go over here, and I'm going to then position train number 1 because he's a westbound. Position train, accept, and it's going to be number 1, the West Hotshot. There it is. Since I don't have detection, whenever I put a label on a chunk of track, it immediately turns it red. It says it's occupied. Okay, hard to see, but the color is almond of train number 1. And before I do that, what I'm going to do is okay, so now I have a train on the track. So if I do a left mouse click, it turns into this crosshair, and I can move the train label. If I do a right click on the train label, I get that one line out of the train table screen. So right click lets me edit the train, left click lets me move it. If you notice that the color is kind of this almond, if I use my page up and my page down keys, I go through the train that have crew assigned to them. It turned blue. What that says is that it's blue, which means then that the arrow keys will move the train. So what happens, let's walk through a little scenario then. Crew of train 1 calls in. Dispatcher, this is train number 1. Dispatcher says, go ahead, train number 1. 1 says, I'm ready to depart the siding at Y for the main track at the station siding. And sorry for the names here. Dispatcher will then throw the turnout, set the signal, as soon as I catch it, set the signal. Come on. There it is. Then dispatcher would say, dispatcher calling train number 1. Train number 1 answering dispatcher. Train number 1, you have permission to depart from the siding at station Y for the main track at siding, and hand throw the switches on the way. Train number 1 says okay. Then we sit back, and a little while later, dispatcher hears train number 1 calling dispatcher. Dispatcher answering train number 1. Go ahead. This is train number 1. I have arrived at siding. Dispatcher, have you lined all switches back to their normal and locked position? Train number 1. Yes, I have, dispatcher. So then the dispatcher uses the arrow keys. And that's how it works. Okay, now let's make things a little more complex here. What I'm going to do is let's show you how to tie it into operations. And this is totally optional. You don't have to use operations with TrainStat. So what I would do is go to network. First thing to notice is this CAT's IP address. That's the address on the network of this computer. I go down to operations. And since I'm using the operations on this computer as well, I don't need to fill anything in. If it's on another computer, I'd have to fill in either the name of the computer or the IP address. Click on connect operations and accept. Now I'm going to do let's put another train down here. We're going to do train number 2. And that's going to be the eastbound. I'm going to accept. He's right there. And I'm going to go up here to operations now, and I'm going to build train number 2. And you'll see, interesting enough, operations says it's partial 17 out of 12 cars. I don't know how that happens. It says we've got 17 cars in train number 2. If I go to train number 2, click on it, and notice for some reason it says I've got 15 cars. So I don't know why the two are different. So it may be how I've got operations set up. Now I'm going to do something else so I can build it. What I'm going to do is I'm going to run TrainStat. Go to TrainStat, click on it. It's in the same folder as Designer is. And I'm going to tell it how to connect to, okay, first of all, I need to do is come down here to make sure on CAT's network, I've got start TrainStat service checked. So that needs to be checked first. And again, its IP address is 192.168.206.1. I go up to TrainStat. If this is on another computer, I put 192.168, whatever it was. But since it's the same computer, I can leave that blank. And I'm just going to say I want to connect to CATs. There it is. So this should look identical to that. Okay, because it is. Okay, so this, now I want to assign a crew. And there are various ways of doing that. One way is I can assign a crew to train number 2. Go over to here, and we'll put Ringo on it. I now have an accept button down here. Click it. Come back down to here. Notice that it's almond saying the crew's been assigned. I will go page up, make it blue. Throw my switch, set my route, and notice it won't let me. I've got interlocking, so it won't let me run the trains together. So I will go into the siding like that. And dispatcher calling train number 2. Train number 2 answering dispatcher. Okay, train number 2, you are cleared from the yard to the siding at siding, and set all your switches. Train number 2 says affirmative, dispatcher. Train number 2 takes off. I'm sorry. Train number 2 goes into Spur. He's got work at Spur, so he says, this is train number 2 calling dispatcher. Dispatcher answering train number 2. Go ahead. Train number 2, I'm at Spur doing my work. Dispatcher rolls it up. Now notice we have in TrainStat, we have the location of where the train is. We have the time it arrived there. And furthermore, the number of cars has been adjusted in operations because CATS is telling operations that the train number 2, where it is in operations, is adjusting the consist appropriately. Okay, so with all of that, let me go back to here and let's go back to the chalkboard. So we talked about all of this, what the mouse buttons do. Here's an example of a Yardmaster screen. Again, I'm sorry it's blurry. It's what my contact sent me. And let's look at the next one. It's clear. This is from the Montana Rail Link. Basically a status screen, a Yardmaster screen. Here's an, I'm going to bring up my laser cursor. There's the trains, lead engine number, the time it last reported in OS, the OS, number of loads, number of empties, how heavy it is, the length, engineer, conductor, hours of service. In other words, when he goes dead on the law. They don't populate horsepower per ton. Offhand, I can't think of what these other things are. That gives you the kind of information that you might want to see in a TrainStat screen. And here's, again, to show you that TrainStat can be heavily customized. So you can add colors, you can add check boxes, you can add your own fields to it. You're not limited to just what CATS gives you. Integration with operations. Operations, that's JMR car routing. CATS tells operations where trains are. Operations then tells CATS how long, how heavy, how many cars are in a train, and that information can be shared with TrainStat. Let's talk about if you were in a larger type of layout where you have multiple crew positions, you might assign one to be the train master. And the life cycle of a train would be the train master would build it in operations. He would print the manifest, give it to the engineer. He would then assign the crew in TrainStat. At that point, the dispatcher would move it around the territory and he'd tie it down or terminate it. And when he terminated it, then the train master would terminate it in operations. So I did all that, demonstrated the magnet board. So let's now show you how to tie CATS to the actual railroad itself. And that's more or less what I'm going to do. We'll need that. So let me go back to here. Okay, I'm going to get rid of some of this stuff. I'm going to get rid of this. And I forgot to do something here, but I'll wing it. Let's continue. Let's save and continue quitting. It'll take in a moment. I'm going to get rid of this one. I don't want to save the changes. Okay. We're going back to designer because now we're going to tell designer how it talks to the layout. Go back to this screen. If you remember, this was again from CATS 102 and how how system names are constructed. You need the profile, you need the type of GMRI object, and you need the address. So we go back to here. Let's put a, actually what I'm going to do is I'm going to open up the full one. I've added decoder information on this version of the layout for everything. It looks the same because it's basically the same track plan. So let's go to here. And here's how I define a block. Again, you go to details, go to track ends, go to define block. Now you put stuff in the lower square. And I can do a magnifier if you want. There we go. Okay, so consequently, the IS came from the IS of the slide over here. In this case, I did an IS. The example, I did an LT. The address comes from that part. I give it a name. You only have to give it a name once. So typically, I just said throw. I get a throw report from the layout when it's occupied, and you get a close when it's not occupied. So that's how that's all there is to add the addresses for the decoders or for the detection. And I do an accept, Okay, let's talk about, let me go back. I'm going to get out of magnifier. I need a bigger screen. There we go. Okay, go back to here. Cursor. Let's do a turnout. Turnouts are the most complicated. And I'm going to do one right here. There we go. And I go to details, track ends, define my switch points. I get something that looks like this. Going back to here. I'll make this bigger for a moment. Okay, if we go to Bruce Chubb's book on turnouts, and this was in, I think it was Herding Cats 104. We talk about what's the difference between the different kinds of turnouts that Bruce Chubb identified. Basically, it's who can control, who can move the points, and who can lock and unlock the turnout. So that's the difference. Now, if we go back to one more here. Okay, the top part is for the turnout. This row, these two boxes are for when the layout reports that the crew has unlocked the turnout. That's where you put in the messages you get from the layout to know that when it's been unlocked. These are the messages that the CATS sends to the layout when the dispatcher gives a track authority. In other words, it unlocks the turnout. And what this could do is it could turn on an LED. It could turn on, for example, a relay inside the turnout, so that's actually unlocked. It could do a bunch of things like that. This part, there's two tabs. One tab is for the left route, going this way. One tab is for the top route. We talked about normal. Oh, if it's a spur, like this guy is here, I check that. Checking spur means that the dispatcher does not have control over that turnout. He can click on it all he wants. It's not going to move. But you still may put in, okay, then this tells you the various routes. So for the left route, this box is the command that CAT sends to the layout to move the points. So I put something in here for a spur, but that's because I may turn on, for example, override, so that CATS enforces that the train crew has unlocked the spur before they can move it, or I've got a something routed through there. So CATS would then go out and actually reverse the points, even though the dispatcher can't do it, CATS can do it. So anyway, here's the command that moves the points. If I'm using either exact or positive feedback, here's where the feedback comes. And typically this will match this, like that. If I'm using, this is for when the points are in place. So when the points move to the normal route, the layout would say it would send me this message. If I'm using exact feedback, which is I put a sensor on both sides of the turnout when it's in diverging and when it's normal, this would be for the diverging. Tell me when it's in the diverging position. If I wanted to use software locking, this would be the case where the crew then, for example, on the throttle, they throw a switch and on the throttle, the CATS sees it. CATS checks to make sure that the point movement can be allowed, and then this would be the message that would be sent from the throttle saying I want to move the points, and then CATS would then use this command to move them. Okay, so that's in a nutshell, that's what all this stuff does, and that covers all of Bruce Chubb's cases and actually a few more. What else have I got here? Let's see. Okay, so, and let's pick up some signals. Go to details again, track ends, find signal, go to details. CATS has looked at the indications that signal will generate. Here's the head 0, the top head. Here's head 1, the bottom head. And it says, I need to generate, I need to be able to do a green, I need to do a yellow and a red. So here's where you put in the decoder commands for doing green, yellow, and red. If you have discretes, for example, the SEHC kind of lumps them together. It's kind of a funny, really funky kind of signal generator for controlling signals. But if you have something like CMRI, you turn on the off command such that when CATS change from green to red, for example, it would do the off command. It would do the opposite of the close to turn off the green before turning on the red. And okay, that's pretty much that's how we do that. Let's see if anything else. Okay, and I'll do a real quick. Let's run it as attached to the layout. Run CATS again. Same profile, same problem. We gotta wait for GMRI to open up the operations simple server. If I don't have simple server check, this comes right up. And it's got to be close to getting done. There we go. And we will open. And we'll do CATS users. And we will do full. And notice this time, indeed, when I sized the window, it fits perfectly. What I forgot to do last time is I want to do a start recording replay. If I do a start recording, then CATS records everything that happens on the layout. And if you get a crash, if you end the session and want to come back to it, then you can do a replay, and it'll replay everything that happened in the session up to the time you quit. And I wanted to show you that, but I forgot to do the recording. Anyway, okay, the other thing, since I don't actually have this hooked up to a layout, I'm going to fake it this way. I'm going to bring up GMRI sensors. So what we'll do is I'll position a train here, and we need an eastbound, so I'll do 152 like that. And I'm now CTC, and I'm now attached to the layout. So I'll set actually what I want to do is I want to go into the siding here. Okay, so I throw the turnout. Notice it's out of correspondence. There is no linkage here. That says that CATS is waiting for feedback from the system before it connects that line. And that line is called siding left report. And so now we get the report back saying it's in the diverging route. And so then I throw the signal. This is, let's see, this is yard right detection, if I remember right. And you notice that the train labels then follow the detection. I don't have to do anything special. It just automatically happens. Siding left. And I'm clearing them up behind me. And I'm on the siding. And that's pretty much it. I guess I'm willing to entertain any questions now. Want me to stop sharing the screen, Jerry?
Yeah, that's fine. So just to reaffirm what I've been saying the last couple of weeks, I've been working on a series of segment videos that'll dive into one specific area of what Rodney's just breezed through, because he really did it at a high level. I mean, you could talk for half an hour about one specific piece of what he presented. And so those videos will start showing up in the coming days on the they'll be announced. You'll get an email as they're posted, but you need to go back and find them later. They'll be in the group's web page. Down the left side, there's a link for Wiki. It's like a Wikipedia type of thing. And there'll be an index in there with links to all the videos as well. So I've got a lot of the snippets done. I did them in batches, and now I got to split them up into their individual parts and do the post-production and get them uploaded. So that'll be coming soon. So with that, anybody have questions for Rodney?
Yeah, I actually had one. I was just watching Rodney set up a route and then busted halfway through, and it occurred to me, do we have time locking? Can we implement that?
You mean running time?
Yeah.
Not yet. I've got a version in which I actually do have running time.
Cool. I mean, I'd like to, set something small, not enough to screw up an op session if somebody blows it, but enough to make the dispatcher just a little hot under the collar if they make a mistake.
Yeah, well, the way I've got it set up, like I say, this will be, I don't know, 6 months. I'm not sure when. I've actually had it for quite a while. I've got time locking involved, and in one of the appearance pull downs, you can set how long you want running time to be. It goes, I think, from anywhere from like 5 seconds to 30 seconds or something. So that's coming.
Dave Miller?
Okay.
Rodney, let me clear up something to here under clear and copy. Clear copies everything, and copy only copies the track. Is that correct?
Yes. Clear is like an erase. It's like cut. So it takes everything off everything that's under the red cursors off the screen.
Okay.
And it
copy
puts it on
only copies the track.
And copy just basically copies the track, and it'll copy also if you're ABS or CTC or something like that.
Okay, thanks.
Inspector Dave.
I watched a YouTube video of somebody's layout here the other day, and that guy was running cats, and he also had an option on there. Instead of, he had fleeting, but he also had in that little box something called stacking. Are you aware of that, Rodney?
Oh.
It was the CATS program, and the drop down. I'm going to have to send you that video link, and you can watch that. He did something then to your program where he has stacking on there, and he explained what stacking is. Anybody here understand what stacking is? Raise their hand.
I've heard the term, but I thought it was synonymous with fleeting. Well, maybe not.
No, not quite.
It's like super fleeting.
Yeah. Well, anyhow, he's added it to your program, so that's kind of cool. And I'll find that link and I'll send it to you, Rodney. Anybody else? Jerry, I don't have anybody else's email, so but the only other one I got to be Jerry. If you want it, you can watch it.
Yeah, that'd be great.
I'll send it to John too if I remember. You're getting too much information now. That's I'm approaching 70. It's overload.
You could also post it to the list and just reference the Herding Cats 106.
All right.
Jerry, can you just kind of be the switchboard there and forward the stuff that would be of general interest?
Sure. No problem. Mark Stafford, I believe you had a question. You're on mute. We still can't hear you. Let me see. Yeah, looks okay at this end. No, we're not hearing you. All right. Anybody else?
Rodney, a couple things with the operations side. Is there any reason to or any advantage to go into operations if the layout doesn't make use of car forwarding utilizing operations?
No.
I didn't think so.
Totally optional.
Okay. Well, because I looked at TrainStat and I thought, okay, that might be an option, but I thought, well, JMRI operations, because Gary's not using that, and that's where we were thinking of doing it. I will say one thing that I found, if anybody's doing it, at least with me being a CMRI user, when you get into some of the signals, just one thing that, and maybe you've seen this, where you go into set the signals where it says thrown or closed. I know that in the case of, depending upon the type of hardware you're talking to, or whether it's a catch chain or an internal, whether it's thrown or closed will depend upon whether it turns that particular item on or off. So you have to kind of play with your logic in your device that you're talking to figure out which one it's going to do. It's not just closed is, and I think in a chain actually activates it. Where in closed on a CMRI output will actually turn it off. So just little things to keep in mind. So.
Anybody else? Mark Stafford.
Yeah, I'm back. Now can you hear me?
Yes.
Yes.
Sorry about that. I had to break away and come back again.
It just took long for the noise to get here from Australia.
Yep. I'm thinking of using your stuff, Rodney, from left field. All right. I'm in the throngs of building a throttle that I can grab hold of tonnage and number of cars and use that information to load into my throttle to give the appearance of load on the train dynamically. All right. So one of the things I want to find out from you is all that great stuff you've got in the TrainStat stuff. Can I get at that to load in via, say, an iPad on Bluetooth into my throttle when I connect up to a bunch of cars?
Yes. And the answer is you don't. Okay. You got two ways of doing it. You could either look like a TrainStat client.
Right.
I can send you I've documented somewhere. I've documented the message set. In other words, the messages that you send. But probably
the strings.
The strings. Probably the easiest way would be go directly to operations itself.
Yeah. Okay. Because I don't know enough about this stuff to know what I can do. At the moment, I'm pressing buttons, load buttons, like you do on a proto throttle to do tonnage, from low, medium, high. But I don't actually want to do that. I want to actually load how many ton and how many cars. How many ton tells me loaded and empty cars, and how many cars tells me brake delays. So I can calculate both and then have all of that stuff dynamically feed back into the processor, and from there have the train react as though you just hooked up bucket loads of weight.
Right. Yeah.
Right?
So, like I say, probably the easiest way would be to go directly to operations. And if you're a programmer, I can tell you the file to look at in CATS that'll do that.
Yeah, I'm only one of like a number of people working on this, so we need to spread it around.
Mm-hmm.
But I'm the representative,
Sure.
hanging out in the. I've got fairly shy coders, shall we say. The second one is we're talking about using an iPad as the conductor's screen so that we bring up his switch list on the iPad, and we have this connection between the iPad and the throttle on Bluetooth. So we can, the idea is to select the loco type and select the loco on the iPad so the conductor allocates the engine to the train, right? And the conductor is in charge of the train, but he can't make it move. He hasn't got the throttle. The driver's got the throttle. So you're following me? But he is responsible for operating the switches. So I'm thinking maybe CATS in a, like looking at it from a left field, can I just use CATS to be turnouts in dark territory, for example? So I drive my train into a station and then have the iPad moving the turnouts around to be able to switch cars into this siding and out of that siding. But I'm focused on my train, only my train.
Hey, Mark,
as a conductor. Yeah?
Mark, I would suggest a different approach. I mean, with CAT, you've got to have the CAT system's got to be connected to the layout, whereas your iPad isn't going to have a direct connection, and I think the easiest way to do it would be with Panel Pro. You can create a Panel Pro diagram. We're not getting into a USNS machine or whatever. But what a lot of guys do is they will make what we call signal repeaters for around their layout. So if you have, say, signals that are on the layout that are at a bad angle for the operator to actually see them, but they're facing the right way for the miniature train, they would put an iPad or something up along the wall, and it's actually a Panel Pro panel that's connected to the JMRI computer via Wi-Fi. You can load individual panels. I mean, you can create like 10, 15 panels, one for each switching location. And then from that particular iPad for the repeater, you call up the web page of just that one panel, and it shows all the signals. That's the common use. You just as easily could have an iPad going around where a person pulls up a switching layout, a panel for a particular switching area, and it gives them the diagram of that area. They can throw the switches, but it's not going to give them any throttle access. They can't do anything with signals. You just have a stripped down panel for them.
Yeah, that's sort of where I'm coming from, but I just don't know the best way to implement it. And remember, what I'm trying to do is build a pair of functioning devices, which is an iPad is one side and the throttle is the other side. And the interaction between the two determines load, because I can't make the throttle talk to Rodney's code because that's a DCC thing, but I have got Bluetooth access into it. So I can use the Bluetooth to do lots of out there things like, are you on a slope? Yes or no.
Yeah. I mean, that's really
right.
beyond the scope of tonight's talk, but that certainly would be an interesting bull session to have some night.
Yeah, but that's why I wanted to sort of talk to Rodney about it, because, and I've talked to Seth about this too, about using RFID to do OSing, so we make sure that when we pull a loco out, it's actually hauling the load that we expect it to be hauling.
Yeah, interesting concept.
Because what I'm trying to do is up the ante, like by a whole new level of difficulty for a driver to actually make the train move, right? Because he's got to take into account load, slope, the brakes. Like, he can't move the train until the brakes are up to pressure. I'll make him. He won't be able to move it because the throttle won't work. Like, he's buggered. So I get that I'm out of scope, but I need to start somewhere.
Yeah, no, I got you. Looks like Spectre Dave's checking out, maybe.
Yeah. Like, I'm quite happy to talk to anybody who's interested in mugging around with this stuff. Like, we've been doing it for 2 years so far.
Yeah.
Yeah.
Mark, it's Ken.
Yeah.
Quite a bit of the operations, I'll call it database from this view, is exposed. And what's nice is actually a lot of it is exposed also through web calls. So there's a few different possibilities of how you could easily grab this information for the train that you're dealing with, for your throttle to then know how to modify. Of course, Dan would be the one who knows all the ins and outs of that, and he responds emails on the JMRI list rather regularly of, okay, if I wanted to access this or that, how do I do that type of thing. So I'd say actually there's a good chance most of the parts are already out here, and it's just a matter of knowing exactly where to dig.
Yeah, that's what I sort of think too. I think I can almost taste this working. In fact, I have got it working. I can control a loco with this thing. Right? It works.
Well, the thing I find is funny is I've mentioned this type of capability as one of the things that the parts are here. Somebody just hasn't taken the time to put them together so that you would get a realistic train behavior based off of the system knowing, okay, you've got such and such type of engine. So on the one hand, it's looking at the JMRI roster to see, okay, your lash up has this, and this locomotive, so that gives you X total horsepower, so forth. And then
we've done that.
And then the next part is, okay, so what's behind the coupler? And mix of loads and empties and all that other stuff. Conceptually, all the data is there. Is just figuring out the right way to dig it out. Right now, I'm looking at the class hierarchy of some of the parts to see where it likely is. And just off the top, I haven't looked deep enough in this part, but looking at some of the documentation, yes, it can be found. It's just, it's going to take a little bit.
Yeah, somebody just wrote a note about looking at Jim Moy's software. I did exactly that, and I was working with Jim Moy before he died to try and get through some of this stuff. But I think that was before Operations Pro came out.
Well, the biggest thing I'd say is operations has been growing now. It's coming up on at least 8 years at least. What's been very interesting is what Dan started with, and basically every time somebody comes up with a reasonable sounding idea, he's frequently been able to add it into the rest of the system. Yeah.
Yeah, I think we're on the threshold of another jump in what we can and can't do. We're sitting awfully close to, and we're talking about relatively cheap electronics to make it happen.
It's
like
amazing.
$10.
It's amazing.
$10.
It's amazing the door that opens, because as soon as you have your throttle knowing what your tonnage is, and it automatically adjusts basically your speed tables based on that tonnage, then it opens the door to, okay, you're going down grade, and if the operator forgets to put on the dynamic brakes, maybe it starts going faster and faster, and you get a runaway. I mean,
Yeah.
sky's the limit. I mean, there's a lot of stuff you can do with that information.
Yeah. We're looking at calculating the size of the wheels, the tractive effort, the size of the grate. This is steam, by the way, we're doing. All of those sorts of calculations. So when you load the parameters of XYZ loco, that loco, the characteristics of that loco will be reflected in the engine. So we'll be able to haul so many carriages up and down XYZ hills. But if you get a smaller loco, you can do less because the calculations say you've got less tractive effort.
Right.
So the actual throttle changes its personality depending on what loco you connect up to it. And it all makes sense, and it's all calculable. It's like you can work it out. You do shitloads of calculations over and over and over and over again. And it's easy.
Yeah.
And like I said, we got it going. It's going. It's working.
Any other
It
parts?
doesn't look very nice at the moment. Hey? So, yeah. So, Rodney, if you're happy to send me some info, I'd be very happy to look at it.
Okay.
Because at the moment, we're pressing buttons to change load.
Actually, what's funny is I just went digging and found that there is actually a method out there, construct train weight. You pass in the name of the train and it comes back with a string of the train's tonnage as known by operations.
Wow.
That'd be cool.
Yeah,
I'd like
exactly
that.
That's what CATS uses. I had Dan put that in there.
Oh, okay. Yeah, I vaguely remembered some of that because otherwise I was looking at, okay, you'd have to iterate through other things to get it from the cars and, pull a lot of different pieces together. I'm saying, wait a minute. I know one or two of the menus has most of that already constructed. Now, the big trick there is, okay, is that dynamically updated as the train adds and drops cars? Now, that gets back to the ops conductor screen, because one of the tricks there is that you can have it that you don't build the train and say, oh, okay, everything went exactly where it wanted to go. Instead, as the train moves along, the operator has to hit the buttons on the keypad to say, okay, I got to town A, I did the work at town A, all those cars are now updated. You move to town B, update across your whole travel. Most people
that's what I was thinking, Ken.
That way. But
but if the throttle required that, I could easily see you having a conductor, two-man crew, walking along with the iPad, saying, yes, I updated this and I OS the train now, and now the train, when you move out, has new characteristics. Updated characteristics by the cars that you pulled and the cards that you dropped.
Right. The only thing that the operations window version of the conductor doesn't do, but the desktop version does, is you can actually edit the train in the middle of a run. So on the desktop, I'm actually able to go and say, oh, I got to town B, there wasn't this car to pick up, so I didn't pick it up. And basically keep the list right, or to flag that, okay, here's an unknown, this car, it was missing. Now it becomes unknown, but the system knows, okay, here's the great unmatched cars, and we'll figure them out later. Because then it would keep the list for your train in the right size. In other words, you actually still have 12 cars or 10, and not just what it expected to have. And
I hear what you're saying, Ken. But
Yeah.
I would use Seth's RFID to do the correction as you leave that yard. Yeah, ask Seth how many RFIDs I bought. I bought a few, didn't I? The occasional one or two.
Steve Davis actually did an integration of my hardware reader, the ones you have, with JMRI Ops. So I think you could leverage that. It worked really well, actually. Like I was at his layout a week before I was in Melbourne with you last year, and it was fantastic. He had effectively a hump yard where it would just show you what you did with the next car, even though it was flat switching, but it just served up the list based on reading the tags. So that information is all there. And, Rodney's got, a good deal of the dynamic information you want already coming out of ops. So, it seems like all the software pieces are there, although I'm certainly not the guy to stitch it together. Ken would be much better at that than me.
Yeah, I'm not the guy either. I'm the idiot trying to haul this together. But I do think it is very close to working, extremely close to working. And if we can get it working, man, oh man, we're going to change the world. It would be so much fun. Like I say, Rodney's stuff is the same. Like I want to have signals. I'm 1925 with somersault signals, so I don't have a problem with not seeing the signals from a while away. And I'm in OSCAR, so they are like a foot high. They're not little things. I want to run those, and so. But I want to add. I don't know how to say this. I want to expand what's capable of being done a bit or a lot. I don't know how much it's going to take. But I'd be happy for your help, Rodney, if I could get it.
Sure.
All right, I got to wrap this up for tonight, guys. Thanks for joining. Thank you, Rodney. Everybody have a great holiday. Stay safe.
Yep, you guys too. Bye-bye.
Thanks, guys.